So I've listed the sine and cosine ones up here. The tan one we will use a little bit, it is on there as well. But when you have sine 2 theta, okay, that's a very easy one to evaluate. It just goes straight to 2 sine theta cos theta. But when we have cos 2 theta, there's 3 possibilities it can take. And so part of the problem we're going to have with some of these questions is like, well, which one am I substituting for? And that's going to require a bit of foresight, a bit of trial and error. And then the better we get at it, the better we'll be able to see which one we should use. Now, our assignment, our folio, is going to be around proving these, so I'm not going to go through any of those proofs just yet. It's very scaffolded, and we will just make a start on that soon. So let's get up here, and we've got, given the theta's pi on 3, we're just going to prove it for one inductive case here. Prove that cos 2 theta equals cos squared theta take sine squared theta. Okay? So we've got theta is pi on 3, and we're just going to start with the left-hand side. Okay, the left-hand side is cos of 2 theta, which would be cos of 2 times pi on 3, which is cos of 2 pi on 3. Okay, so look at our unit circle. 2 pi on 3, cos is the x value, so that's minus half. Okay? And then we'll go to the right hand side. Okay, we're going to leave that there. We'll evaluate this simplifies to minus half, and so then we're going to apply that pi on 3 to the right hand side and check that they're the same. So on the right hand side, we're going to have cos squared of theta. So what that means is cos of theta squared, take sine of theta squared. Now the angle is pi on 3, so we've got cos of pi on 3 squared, take sine of pi on 3 squared. So we're looking at the unit circle, the angle pi on 3, cos is half, and sine is root 3 on 2. Okay, let's evaluate these a bit. We're going to have 1 on 4, take 3 on 4. Same denominator, so we can perform this. Minus 2 on 4, which is minus half, which is equal to the left-hand side. Okay, so we've got left-hand side, simplifies to this, right-hand side simplifies to this, right-hand side equals left-hand side. Proof complete. Q indeed. Okay. Cos theta is 2 on 3. Find sine 2 theta. So let's jump over here at these double angle identities. Sine 2 theta is 2 sine theta cos theta. Okay? Sine 2 theta, what it wants us to find then is not just sine 2 theta, it wants us to find 2 sine theta cos theta, because these are equal to one another. We've already got cos theta. Cos theta is 2 on 3, which means we need to find sine theta given cos theta is 2 on 3. So 2 processes we can follow, a skill we've done before. Alright? So we can draw the triangle, the right angle triangle with theta. We can label it A, H, and O. Cos is A on H, so that's going to be 2 on 3, and then I'm going to use Pythag to find O. Alright, it's O squared plus 2 squared is 3 squared. O is going to be 5. So O will be square root of 9 taken to 5. Okay? So from here, therefore, sine theta is O on H, so it's root 5 on 3. Therefore, sine 2 theta is 2 sine theta cos theta, which is 2 times the sine value, and then times the cos value. Okay. So we can do the triangle there, all right, to find sine. The other one is we've got cos squared theta plus sine squared theta is 1. We've got cos is 2 on 3. And then this is an equation that you can go ahead and solve for sine theta by itself. So that's the other procedure if you don't want to use the right angle triangle. I think we're familiar with both. Alright. Jump over here, question 3. We've got cos 2a is 3 on 5. Cos 2a is 3 on 5. Find both cos A and sine A. Well, we're going to use cos 2a, we're going to use one of these expressions for it. Now, it's not going to be very helpful if we use this one, okay? Because then we're going to have cos squared theta take sine squared theta is 3 and 5. We've got 2 variables and only one solution, so that's not helpful for us. So we're going to isolate it so we get one variable. It's not going to matter which of these we use. Let's go with this one, 2 cos squared theta take 1. So cos 2a equals 2 cos squared a take 1. And we're told that that equals 3 on 5. Okay, so all I've done so far, I've substituted 2 cos squared a take 1 for cos 2a. So this is going to give us 2 cos squared a is, I'm going to add 1 to both sides to cancel it here. So that's going to give us, 8 on 5 over here. Then we will divide both sides by 2 to get cos squared by itself. And then we will square root both sides to get cos of A is the square root of 4 on 5. Root 4 on root 5, 2 on root 5, plus or minus, we're not given a boundary. Okay. Now we've got cos there, we've got cos is 2 on root 5. We're asked to find both sine and cos. So again, we've got cos, we need to find sine. We could again do the triangle process. This time let's do the formula. We've got cos squared theta plus sine squared theta is 1. We've got cos of A, or cos of theta, is 2 on root 5. And we'll solve this. We're going to have 2 on 4 on 5. We'll get sine squared theta is 1 on 5. So sine is plus or minus 1 on root 5. Okay. Cool. Is anyone still on this board? If not, I'll spin it around. Okay, and we'll just go through question 3 here, and then we'll make a start on the exercise, and then we might go through some of these harder ones a bit towards the end. Big, long exercise, this one. So we've got question 4. Use a double angle identity to simplify. 3 sine A cos A. That's our first one. And then over here, sine squared 3x take cos squared 3x. All right. So let's have a look at our double angle identities here for the first one. We've got 3 sine A cos A. Now, if we look at our identities, we've got we've got 2 sine theta cos theta, so it's reasonably similar, but the difference is this 3 and this 2. So we've got to think, how can we write this so that it looks like that? Okay? So I'll show you first, and then you'll know, of course. If we write that as 3 on 2 times 2 sine A cos A. Okay, if you perform this expansion, all right, you're going to have 2 at the top, 2 at the bottom will cancel, and you're left with what we started with at the top. Okay, so they're the kind of things that we're going to sort of be, they're the kind of substitutions we're looking at here. And so we've got 3 on 2, 2 sine A cos A. Now it is in the exact same form that we have over here, 2 sine theta cos theta. And so we can simplify that to be sine of 2 theta. Or in this circumstance, this whole thing simplifies to be sine of 2A. Okay? Now, when you get to these questions, they will start off fairly easy. They'll be easier than this, and then they'll get hard like this, where you have to make those kinds of substitutions. This one over here is going to be a bit the same, a bit of a challenge. We're looking at a double angled formula. I'm looking at what I've got written there, sine squared of 3x. Now, it may be useful, for this question, we can perform these kinds of substitutions as well. It may be useful, just so we're not getting so confused, to go let theta equal 3x. Okay, because maybe that 3 might throw us out a bit. And then what we've got is we've got sine squared theta, take cos squared theta. And we're going, now let's see if there's a double identity that's similar to that. Here we've got cos squared theta take sine squared theta. So this is the question, how can we write that like this? What can we do to it? And we can factorise the negative and put it as cos squared theta take sine squared theta. Okay? If you expand that, okay, you're going to have the exact same thing that we've got up there. I'll switch the order of them around as well. So maybe I'll do that in 2 steps, just in case we get confused. We could write it like this. Okay, we can pull the negative out the front, and then we've said the order isn't going to matter. Like when you add addition and subtraction, they're the same. So we've got here cos squared theta take sine squared theta. Okay, and what does that simplify to? If we have cos squared theta take sine squared theta, it simplifies to cos of 2 theta. So here this is going to be minus, and then in brackets cos of 2 theta. Okay, we're almost done. But we defined theta as 3x. Okay, so that means down here we're going to have cos of 6x. 2 times 3x is 6x. Now with a question like this, okay, not a necessary step at all. Okay, you don't have to do that. I'm just trying to do that to sort of simplify it so you can see the operation that's going on. So in terms of what's an important step here, really, this is a 1-mark question. Okay, and this is the answer. And so we're going to get good enough at recognising these double angled identities that we'll be able to go from there to there. All right, but it does start a fair bit easier than these ones, and then increases complexity. So I'm going to pause there. Are there any questions at this stage with what we're cranking on? Okay, so let's have a go at some of G, and we'll see how we track along with it.